Hello, hopefully this is recording, but here is the plan for this review. So we are going to read this file that I've made called points.txt, and it has a bunch of random 3D points in them. So the first thing will be the x-coordinate, then the y, then the z-coordinate. And this file, you know that you're at the end when the last point that you read is -1, -1, -1. So that is this points.txt file that we will be reading. So we're going to take it and read it into a new array of points that we make for ourselves. And we are going to walk through that array that we make that holds the points from the file. And we're going to iterate through that and figure out which point was closest to the origin. And we'll return a pointer to that. And whichever one that was, we'll print it out. And finally, we'll end up deleting that array that we made because we'll be making it on the heap. And then to get practice with other things that are on the study guide, we're going to first write a makefile just to make sure everything compiles. We're not going to use any default rules so that we know exactly what's happening. And then we're going to draw some memory diagrams for some functions that we're going to be defining. And then finally use Git. So I'm declaring this constant max points. It'll be the size of the array that we're going to define. And here are the 4 main functions that we'll be using in this program. We're going to put them in different files, but right now let's just look at these definitions. So the setPoint function will take a point by reference and fill it in. It will set its x coordinate, y coordinate, and z coordinate to be those things. So now we have points that are 3D that have x, y, and z. So points will look like this. Struct point double x, double y, and now double z as well. Okay. Then we'll have a function that prints a point when we give it a pointer to one. And this read file and populate array function will open this points.txt file, read it into the array that we pass along. Okay. And then we will also call this function, given that array that we populated with the points. We will go through that and look for the point that is closest to the origin. It's like, in a sense, it's the minimum of all these points in a certain way. So that is what's going to happen. Let's actually use all these functions right now in the main function just to go through what exactly we're doing in order. So the first thing that we're going to do is make a new array to hold all these points in this file that we were going to read. So an array of points, it'll look like this, point arr, and we want to make it on the heap, so we'll say that it's a pointer to the first thing in that array, new point, and we don't know how many things are in the file, but we're going to say that there can't be more than max points, this constant. And then when we're done, at the very end of the program, we're going to delete this array. Just like that. So this AR is an array of points on the heap of size max points. And assuming you don't change it, it'll be 256. And now using that array, we're going to read the file. Read file and populate array. So given this array and the size of it, we will go through the file, this points.txt file, and put all the points into this array arr. And we can't go over the number of max point. We can't go over max points entries. Okay? So this will read points.txt all in one fell swoop. This whole function will open the file, read from it, and write to this array. And remember that you can write the type of an array either way, as a pointer to the first thing or an array by itself. Either way works. So this function, find point closest to origin, will take the array using this style of type. it's still an array of points. So we'll find that point with the array, with its size. Let's see. This might be the wrong way to do it, but we'll come back. We might have to figure out how big this array is. So maybe we should return the size. Like this. This will be the maximum size, but we'll return the actual size that we wrote to. So there were only 100 elements in this file that we're going to add to the array, and so we want to give back the fact that we were only filling up the array that has 256 things part of the way. We're only going to fill up 100 of those things. Int size equals that. So now we can use size instead. So that's how many things are really in this array. And then we'll get a pointer to that thing. Point with point closest to origin. And that is what this function will return to us. And at that point, I think we're set. So we've used everything here. And then we want to print out the point that was closest to the origin. Okay? So print point will be a function that takes that pointer to a point closest to origin, and then prints it out. So the return type is void, it'll just print a cout. Okay, so that is, assuming we have all these functions, which we're about to make, this is how this program is going to run, and we should be good. All right, so now let's split this up into a bunch of different files. So right now I just have review.cpp, but let's be good programmers working with large code bases, and we will put the definition of point in its own header file. So we'll call it point.h. And we want to wrap this around a bunch of those if and defs that you've seen in your lab to make sure that we can't, to make sure that there's no infinite inclusion. So if it point underscore h, you can put anything here, but it's customary to use capitals that are the name of the file. Define point h and if. So that'll be point.h, and so now, because we're using point in the main function, we need to know what that really is, so we're going to include it. Just like that. And then let's talk about these other files. So point.funcs.h will hold the declarations of functions that work on single points, and point array funcs will hold the definition of functions that work on arrays of points. So these two functions work on arrays of points, this one and that one, and these two functions work on just one point at a time. Here it is, point p and then a pointer to a p, so either by reference or by pointer. So let's make those two files. Point array, point funcs.h will hold these two things. Point funcs.h. I might have included a capital F like that. Did I? Yes, good. And again, we'll do the same thing to prevent infinite loops of inclusion. That's point funcs.h, and now this will be point array funcs.h. These two functions will go in there. And again with the if and defs and things. Array and if. Okay. So now we have all those things in the right places, so we'll include all those things because we're going to use all of those functions. This one lives in point array funcs.h, so we better include that. And this one lives in point funcs.h, so we better include that. Okay, So now we've included all the things that we need to run these functions, and we've given declarations of them in all our .h files. Now all we have to do is go and implement them in their corresponding .cpp files. So here in pointfuncs.h, these are a bit simpler functions, so we'll implement those first. So in their corresponding .cpp file, this will be pointfuncs.cpp, and we'll go and implement these. And it's a good idea to always include your header file, just in case things get out of order or you call one function inside another. So setPoint sets p's x.x, .y, and .z fields with the given parameters or the given arguments for xval, yval, and zval. So the implementation of this, because p is going to be passed along by reference, is there's no stars or anything. We're just going to say p.x equals xval, and same for y and z. Just like that. So this will set a point given a new xval, yval, and zval for it. And this will print that point to cout. And we have a pointer this time. So I guess cout, open parenthesis, then p. We can't say .x. We have to dereference p first, because it's just a pointer right now. And then maybe a comma, and then I could use the arrow instead. That's equivalent. Another comma, p arrow z, and we can close that off. I don't know if I want to print a new line. Maybe we should. Let's print a new line, and that will be the function. So it just prints out the x, y, and z coordinates in a pretty way. So that's pointfuncs.cpp. Now point array funcs are going to be a bit more difficult. So let's go and implement those in their corresponding point array funcs.cpp. So we'll include the header file. And something that I forgot to do in pointfuncs is, because we are using cout here, we better include iostream and also use namespace standard. And because we're already including pointfuncs.h, it'll just get copied and pasted. This entire file will get copied and pasted. So if we include it here, it'll end up in that CPP file. Include iostream using name space standard. So now that'll compile now. And again here, we're going to do a few things. So this function is going to read a file. So think about what library we need to include here. And this one is just going to iterate through points. And because we want to find the point closest to origin, we might need to add another function in pointfuncs that does the distance. So let's do this first. Read file and populate array. So this is going to open points.txt. So we're going to read a file, so we're going to use an if stream. And because of that, we're going to include, or actually we can do it in pointarrayfuncs.h. Include fstream and also using namespace std. So now we have access to fstreams, which will give us access to ifstream. So ifstream, ifs is the common thing to say. ifs.open. The name of the file is going to be points.txt. That's this file again right here that contains a bunch of points on different lines, but really we're just going to read 3 doubles and then the next 3 doubles. We don't care that we don't care about the white space until we hit the end, and we know we're at the end because we found -1, -1, -1. All right. Read. Well, I'll put this down here. Read from ifs until we hit -1, -1, -1. So that'll be the x, y, and z coordinates of the last one, the one that we stop at. We don't actually read that one. So it's possible that something went wrong. So if not ifs, or there's some other options that you could use here. Bad file or something. We want to not do anything. Maybe We can exit the program maybe, or we could just not read the file at all. Maybe we can just return 0. We didn't fill in any elements of the array because we couldn't. Maybe something like that. Otherwise, now the file's good. If we got this far, the file was okay to be opened. And so now we will get x and y and z coordinates that are doubles, double x, y, z, and maybe we'll start them off as like 0, 0.0, and then we can say while x is unequal to -1 and y is unequal to -1 and z is unequal to -1. I think these need to be ors actually, because we want to stop when they're all -1. So this will work now. So this stops, becomes false when x, y, and z are all -1. Because say x was -1, y was -1, but z was 3, this would still be true, and we could continue the while loop because z was not equal to -1. Only if they're all equal to -1 does this become false. Okay? So that's good there. So we'll read values into x, y, and z, and set the next element of the array. So we better remember which index we're starting at. Int current index. So we'll start at 0 because we'll fill in ARR 0 first. So let's get x, y, and z first though. IFS, get an x, get a y, get a z, and let's see. Actually, because we want to stop when we read this and we don't want to actually include this -1, -1, -1 point, it would be better if we change this to be an infinite loop and break as soon as they're all -1. Stop the loop now. Okay, so that will work better, I think. So now we're going to take that x, y, and z value because assuming we didn't break out, we have a non -1, -1, -1 point to add. So we'll make a point now, or we'll use the array get at the current point that we're trying to access, current index. So that's the point, and we're going to set that point. Oh, but we have a function that sets the point, don't we? In pointfunc.h, set point. So we'll include in this file now, oh oops, this should have been h, pointfuncs.h, so that we can call the setfunc, or the set point function. Set point, that's the point, the array at the current index, with x, y, and z. Okay, so this will set the point at the current index starting at 0 with the x, y, and z value that we just read. All right, and then because we're done with the current index, we better increment it so that the next time we do this, we start setting array 1, then array 2, things like that. All right, and then when this function returns, we need to return the number of elements we added to the array, which will end up assuming if -1, -1, -1 was the first thing that was there, current index will be 0, and that'll work. We could just return maybe current index in that case. If we read one thing from the file, then current index would be, it looks like 1. So I think if we return current index, it'll always work. We can test this later. because I think every time we add something, we immediately add 1 to current index, and because current index starts at 0, this should be fine. Yeah, all right, I'm happy with that. So that'll return the size of the array that we built up. And it was at max size. So also, say this file had 500 points in it. That was bigger than the max points, the size of this array, and we don't want to write past the end of it, right? So what we're going to do is also make sure that we're not going to try and write past the end of the array. If current index is greater than or equal to max size, because say it was 256, we only have indices from 0 to 255, so if it's equal to it, we need to stop as well. Also break. Don't write past the end of the array. All right, so that should be good there. And now we can work on finding the point that is closest to the origin. And I think I want to show off pointer arithmetic and use a while loop to go through this array this time. So let's do that. So current point that I'm looking at will start at the first element, to the first element of ARR, that is the address of array 0, ARR 0. So, and then also keep track of I, maybe like where I am. Int I equals 0, starting from the first element, and then while I is less than size, I'll do a bunch of stuff, I++, and then I'll also advance the pointer, but we'll get to that in a second. Let's see here. So what we want to do here is see if the current point we're on is closer to the origin than the point we currently think is the closest to the origin. So actually, I think we want to start by making a guess. Point closest to origin. And this actually will imply that this array is bigger than 0. So the size, better assert maybe that size is greater than 0, because otherwise this isn't going to work. Equals ARR, and then we can start this at ARR plus 1. Like that. So guess that the first element was the closest. And it's possible, and very likely, that this wasn't the closest one, but we need one to guess with so that we can compare against it later. So then we'll start the other one at ARR plus 1, and I will start at 1 now. Okay? So now we can follow this. So see if the current point we're on, which will be current point, is closer to the origin than the point we currently think is closest, which is this one. So that is like solving for the max of things, or the minimum of things. So assuming I have like an array, let me show you how this is working. We're going to guess that the first element of the array may be 1, 2, or let me do it so that it's not true. 3, 2, 1, 4. So what's happening now is guess that 3 is the min, and then compare the rest of the array. And what's going to happen is we're going to see that we're going to look at 2 first and see, hey, is it smaller than 3? Yeah, it totally is. So we're going to update our guess to be actually 2 now. And we're going to advance our current pointer to what we're looking at. And we'll see we're guessing that 2 is the minimum right now. and then we'll look at 1 and compare it to what we think is the current minimum. And it turns out that 1 is smaller than 2, so we're going to get rid of this again and then guess that 1 happens to be the minimum element, because that's the smallest one we've seen so far. And then when we look at the last element of the array, we'll compare it against 1, and we'll notice that, yeah, this was still the right choice. So eventually we're going to try and guess, we're going to try and look at the end of the array, and then we stop our loop when that happens, and we'll return the fact that 1 was the smallest element of the array. And so this is essentially what's going on in this function. We're finding the point that's the closest to the origin, and it's essentially solving this minimum problem. Okay, so that's what's going on there. Let's go and do this. So we'll check. So maybe we should make a function called distance to origin, because then we can compare. If the distance to the origin of current point is smaller than the distance to the origin of the one that we think is the closest right now, then we'll update. Closest to origin is really current point then. Update our guess, and at that point that should work. And then we also want to always advance our pointer, so current point, the one that we're looking at, needs to be the next one after this. Move the pointer over. So what's going to happen is we have ARR, that is an array of points this time, with x, y, and z in it. Maybe we only had 3 points. X, y, z looks like this in a sense. And then x, y, z, x, y, z. These could be separate boxes if I give myself enough room. There we go. So we're going to start out with current point being, well, actually it'll start at the first element, so not this one. Current point, and then the effect that current point equals itself plus 1. You could just use plus plus. What this is going to do is it's going to say, oh, we're going to update this, and it's going to be the next thing in the array. That's what plus 1 does. And we're also keeping track of I, so it's going to become 1 more. So we stay under size. All right. So in that case, at the end of all this, assuming we have this function distance to origin, we are going to return the point that ended up being the closest. We're going to return a pointer to it, and so this type is a point star, and that was what we were going to return, so that's perfect. Pointer to the closest point. All right, and then we better make this function now, distance to origin. It'll take 1 point. It'll take a pointer to a point, so let's put this in point funcs. Distance to origin, point star p, just like that, and we'll implement it over here. So this will involve the math library, I think. Include cmath, because we need to do square roots and stuff. So should be square root of p's x minus 0 squared, right? So pow that to a 2, and then I think we're going to add all these. Pretty sure that's how distances work. It's that plus that. Because I think the distance to the origin is always going to be square root of x squared plus y squared plus z squared. Pretty sure. Because that would be x minus 0 squared, y minus 0 squared, z minus 0, all that squared. Don't quote me on that. Hopefully that's right. So I think that's what it needs to be. So we can actually get rid of these minus zeros. because the 0.000 doesn't really do anything when you subtract. And I think we can return this, and it better be, sorry, better return a double. And assuming that works, I think we're good. It's possible that I used the wrong thing for PAL. We'll find out from the compiler in a second. But now we have access to those functions because we included pointfuncs.h. We read the file. So we're running it like that. And then, let's see. I think that was everything that we set off to implement. So let's try compiling all this. We'll probably get some errors, but that's half the fun. Let's make a makefile. And so let me just paste all the things that we need to compile. So the main thing that we're making is review. And it requires all these implementation files. Review.cpp needs to get compiled, pointfuncs.cpp needs to get compiled, and then pointarrayfuncs also needs to get compiled. And to compile them, let's just compile them one at a time to object files. So we need review.o, that's the compiled version of review.cpp. Pointfuncs.o is the compiled version of pointfuncs.cpp. And then similarly for pointarrayfuncs, just like that. And then once we have all those things, we can say g++, put them all together, output review. We'll link them. This is the linking stage. And remember that this could have been g++ $caret -o $at symbol. That will expand to this, but we're just going to write it out right now. And we don't want to use any default rules. There are default rules to make .o files, but we want to do this ourselves right now. So this is the way to make review.o. It requires review.cpp, and we compile it into an object file by saying g++ -c name of the file. So again, I could have used this $caret to get at everything after the colon. And so this line right here will make review.o from review.cpp. And the next thing that we need to do is make the other .o files, the other two. So following this pattern, pointfuncs and pointarrayfuncs. So now I can say make review, and it should compile review.o first, then pointfuncs.o, then pointarrayfuncs, and then once it has all of those, it'll run this command. So we should see, in this order, this command, this command, this command, and then this one. See if you can understand why that's going to happen in that order. Assuming that we don't have any errors, which I'm sure we do, it should do all of those things. So let's say make review. I could just say make because review is the first thing. So let's see what's wrong. All right, we have some errors in pointfuncs.h. Oh, so it doesn't know what point is, and that's because we forgot to include point.h here. So now it knows what a point is, because it didn't before. All right, it's going to recompile things. And I think I did it again, yeah, in pointarrayfuncs as well. Well, there we go. And now it compiled. Let's see if it runs. If we did everything right, it'll print out the point that was closest to the origin. And 450, is that correct? I have a feeling that it's not. Did I really make 450? No, there's no 4.0 anywhere. That's interesting. So that means something weird is happening. So let's find out what. Point.h, these are doubles, that's correct. When we're reading pointarrayfuncs, it looks like that's correct as well. So maybe we should test all of these things one by one. So let's see what this array looks like right now. So this is This is me debugging on the fly, and this is good practice, I'm sure. So for int I equals 0, I is less than size, I plus plus. Let's see what's going on inside of this ARR array. Print point, ARR I. And I guess we want the address of that because print point works with pointer. So let's make sure that we're actually reading this correctly. It looks like that's really interesting. You know, maybe it is working. It's possible that it's just printing out doubles in a very weird way. Is this correct though? Let's see. 293, yeah, that is correct. Well, in that case, 77, 36, 36. Either it's not getting the doubles or something else that is odd is happening. So I think it's again this function that's reading files. X, Y, and Z are all correct. Maybe, okay, it was the set point function. I forgot to use doubles. There we go. That will be the problem. I knew we were losing the decimals somehow. So that should work now. And that just goes to show that you don't want it to convert types for you all the time. Read file and populate array. Set point. Something is going wrong. I could have sworn. Yeah, so where is... Well, maybe it's because of the way things got compiled. We need to clean it. So let's remove every .o file, then also review. Sorry, that needs to go here. rm, all that. So now let's make clean. And then make review. This should compile this time. All right, so now it's printing out, yeah, things that look correct. Now let's rerun it. Yeah, there we go. And it should print out the point that's closest to the origin now. Oops, recompile. There we go. So it looks like, yeah, these are very small coordinates. So I would not disagree if that's what it thinks is the smallest one. Let's see if we can find that. 4.78. This one, it looks like. These are all very small coordinates and the rest are quite big, so I think that it's doing the right thing. So this is the point that's closest to the origin. And it ended up getting all 100 things too, because when we printed it, it ended there. So I think we have a correct program on our hands now. Of course, we could write tests, but let's assume that it's correct now. So we wrote a makefile. Let's draw some memory diagrams. So let's see what's going on under the hood when set point is being called. So set point is over here. This is its declaration. Here's its definition. So let's say we're calling set point. Let's make it easier on ourselves from main. So it's going to take a reference to a point that already exists, and then xval, yval, and zval. So let's say we want to set a point, maybe called, I don't know, maybe we'll just call it p. So inside of main, we will have a point called p. And it's a point which means it has an x, y, and z for our definition of this point. In your lab, you only have x and y, right? So right now, maybe it's uninitialized. And when we call set point, it has its own local variables, and parameters are local variables. The one catch, the one caveat is this p, because it is passed by reference. P is not a new box. It is renaming an old box, which happens to be this p over here. Maybe I should give it a different name. So maybe we can call it inside of main, it's called pt, but inside of set point, we're going to call it p. All right, and so we're just giving a new name for this. And remember that you can only call it p. P works in main or in set point, PT works in main. These two are different names depending on where you are in the program. And then set point has its own local variables called xval, yval, and zval. Those are all doubles. Xval, yval, and zval. And maybe it was 1, 2, 3 or something. So as soon as we end up calling this function, we're going to end up changing all this from what it was to this right here. So I don't actually want this anymore, or I accidentally copied it. That works even better. So what's going to happen now is, because we set the point with the values from xval, yval, and zval, there's no pointer, so there's no arrows. We're just going to reset the x and the y and the z of pt. All right, so this becomes 1, 2, and 3, assuming we implemented this correctly. So this is how the memory is going to change, and notice that there are no pointers involved right now. And we can also use the stack diagram for this. So what's going to happen is in main, let's check that. Inside of main, you have PT, which look like this. I'll just say it had those three things, x, y, and z. And then inside of set point, oops. We wanted xval, yval, and zval. Those were the locals, 1, 2, and 3. 1, 2, and 3. So eventually, we're going to call this P, and P lives up here. Whee! There's no real arrows, so I don't really know a good way to draw this. But P is in set point, and it's really referencing this whole thing. Whee! Something like that. Draw like a little lasso. But normally we could just put it right next to it. But I want to emphasize the fact that P exists in set point, and it's a naming point. It's an alias for PT. But we can't say PT inside of set point, just like we can't say P in main. So then this function will set 1, 2, and 3 here, and then this will end up returning. And so xval, yval, and zval, their memory goes away, but we did the job still by setting 1, 2, and 3. Okay, so that happened. And I think that's a good diagram for that. And then also, let's walk through how find point closest to origin is working. So what I did up here, it's very similar to this min operation, but I want to go through this in more detail. So here's the function, find point closest to origin. We have a bunch of different things working. So on the stack,